Sum number 71. Charge Q is placed at one corner of a cube. Charge Q is placed at one corner of the cube. Charge Q is placed here at one corner of the cube. To use Gauss's theorem, this charge should be enclosed in the symmetrical figure.
Yes, sir.
So if I assume one cube here, is it enclosed?
No.
No. So one front cube, one back cube, two back, still it will be outside only from the top.
Yes, sir.
So total how many cube will be required to enclose? Eight,
7.
seven, and one already there. So eight, na?
Yeah.
Yes, sir.
One. Hello? हाँ मैडम. Okay. हाँ. वो 12 CBSE है क्या स्टेट बोर्ड है मैडम? और कौन से कॉलेज में है वो? ओके. आप मुलुंड भांडुप के बीच में रहते हो? अच्छा अच्छा. मैं आपको एक घंटे का फोन करूं मैडम, एक लेक्चर मेरा चल रहा है, ये खत्म होके मैं आपको करता हूँ. फाइन, थैंक यू. Hello? Yeah, see. So I can say if there are 1, 2 backside, one more, 3, here one more, total 4 from top, 4 from bottom, it will get trapped in between. So can I say like this, flux through 8 cube will be Q upon epsilon naught. This much clear? Hello?
Yes, sir.
So what will be flux through 1 cube?
Q by 8 epsilon.
That means you are telling 1/8 of Q by epsilon.
Yeah.
But our charge is not inside the cube. Our charge is at the corner of one of the cube here. So from this corner, this is one face going perpendicular. This is second one and this is third one. We want charge through one face. So this is through entire cube. So flux through, it is actually three faces, say it is passing. Na? One cube means it is three phase. Will be 1/8 Q upon epsilon naught. So flux through one phase will be 1/3 of 1/8 Q upon epsilon naught, that is 1/24 Q upon epsilon naught. This is flux through each phase when the charge is at corner of one of the cube. So option D. First it was inside 8 cube. So for 8 cube, from that we got 1 cube, but that is outside at the one corner. So this is flux passing through 3 phase. 1 cube means 3 phase. But we want 1 phase, therefore we got 1 upon 3 times of 1/8 Q by epsilon naught, which is 1/24 Q upon epsilon naught. Can I clear this? 71.
Yes, sir.
Sum number 72. Also important one. Electric charge is uniformly distributed along the length of wire. So this is one thin wire. Charge is uniformly distributed along the length of this wire. Length of wire of radius 1 millimeter. So 10 raised to minus 3. Charge per centimeter length. Another cylindrical, the charge per centimeter length of wire is given as Q. Okay. Charge per centimeter length is given as capital. So total charge is Q into length. Another cylinder of radius 50 centimeter. Cylinder is of radius 50 centimeter. And length 1 meter, which is 100 centimeter. Will enclose the charge inside, which is on the length of 100 centimeter. So charge enclosed will be Q into 100 centimeter, because this L was in centimeter. Now we want what is flux through the cylinder. Flux is net charge enclosed upon epsilon naught. So 100 Q upon epsilon naught, 100 Q upon epsilon naught, option D. Okay, followed? Hello?
Yes, sir.
Yes, sir.
Okay, sorry.
Done, sir.
73 is theoretical. Gauss's law helps in determining electric force between point charge, no. Situation where Coulomb's law fail, no. Determination of electric field due to symmetric charge distribution, yes. Because with electric field we get flux. Symmetric charge distribution, C. 74. Variation of electric field strength, E. Variation of electric field strength, E, with distance D from the center of some conducting sphere. We know intensity from the center of conducting sphere is 1 upon 4 pi epsilon q by r square. That means till the distance, which is here r, inside intensity is 0. So till that distance becomes radius, intensity is 0, 0, 0, 0, 0. At small r equals to radius, E will become maximum. Then it will be curved such that E is inversely proportional to R square. Here E is maximum, which is K Q upon capital R square. Check this type of figure. Yes, D. Everybody has followed this diagram pattern?
Yes, sir.
Okay.
Yes, sir.
Done, sir.
74. 75, sorry. Magnitude of electric field E in the annular region of charged cylindrical capacitor. Charged cylindrical capacitor. See, there are three types of capacitor: parallel plate capacitor, spherical capacitor, and cylindrical capacitor. Parallel plate consists of two plates, spherical consists of two spheres, same way cylindrical consists of two cylinders, outer is insulated, earth. Now they're telling annular region. Annular region means this circular part. This region is called annular. This. That means that circular region. This. So intensity at any point near cylinder, we know it is lambda upon 2 pi r epsilon, where lambda is charge per unit length. Correct?
Yes, sir.
So can I say E is inversely proportional to R then?
Mm.
So where is that given? C. So any point near the charged cylinder, intensity is lambda upon 2 pi r epsilon. So E is inversely proportional to distance from the axis. Therefore C. Aryan followed this sum number 75. Today we started from 71. हाँ
Yes, sir.
हाँ बाद में recorded lecture post कर दूंगा, देख लेना जो मिस हो गया.
हाँ ठीक.
75 done. Can I clear it off?
Yeah. Yes, sir.
Okay. 76th one. Figure shows pairs of plates with same separation for which pair electric field between the plate is pointing rightward. What is direction of electric field? Can you tell from where to where? This is so basic. Now we have done. Electric field is always directed from where?
Positive.
That means higher potential to lower potential.
Mm.
Electric field is always from higher to lower. Now in this case, who is higher? This is higher and this is
Positive.
lower.
Mm.
This will be direction of field. Correct?
Yes, sir.
So this is not our answer because they want direct pointing rightward. This is pointing leftward. This is high. This is low. Again, it is pointing leftward. B is also not our option. C, minus 200 is high as compared to minus 400. So this will be the direction high to low. This is high and this is low. This is the direction. So which is correct option? This, na?
Yes, sir.
Because electric field is from high to low. Completed till
Yes, sir.
next sum 77. The electric field in a certain region, electric field in a certain region of a space is given by vector form is the E bar is 5I cap plus 4J cap minus 4K cap into 10 raised to 5 Newton per Coulomb. The electric flux on the area A bar, which is 2I cap minus J cap into 10 raised to minus 2 meters square. Flux is a dot product of E bar and A bar. So this is 5I cap plus 4J cap minus 4K cap dot with 2I minus J into 10 raised to plus 3 after multiplying these two. I hope till this you have followed.
Yes, sir.
Now our dot product is I coefficient multiplied. So 5 into 2 plus 4 into minus 1 plus minus 4 into 0 into 10 raised to 3. 5 into 2 is 10. 10 minus 4 is 6. So this will be 6 into 10 raised to 3. है क्या answer? 6 into 10 raised to 3. Option D, I think. D. So done.
Yes, sir.
Yes, sir.
78. Consider an insulated non-conducting sphere. Insulated non-conducting sphere of radius capital R and charge density rho. Charge density rho means charge per unit volume. The electric field at distance r from center of sphere. What is meaning of non-conducting sphere? Is it filled with insulator or filled with dielectric medium? Hello?
Sir, insulator.
So inside this sphere, which is insulating, non-conducting means insulator. So it is solid sphere which is behaving like insulator. Now, when you give charge to this non-conducting insulator, so all the charge will be inside. It will not come on the sphere surface because it is not conductor. Correct, no?
Yes, sir.
तो इसका एक डेरिवेशन में करता हूँ so that you understand the answer. Just wait for 1 minute. हाँ? Hello? Hello?
Yes, sir.
Yes, sir. Yes, sir.
See, whenever we say sphere, there are two types of sphere. One is hollow sphere, other is solid sphere, correct? Hello?
Yes, sir.
Yes, sir.
So when you say hollow sphere, that means actually we are talking about three spheres. It is conducting, or it can be non-conducting, and solid conducting sphere. Hollow can be conducting or non-conducting. And solid conducting sphere, same answer, because charge will be on the surface always. See, if I take this is hollow sphere. Now if it is hollow, then when you give charge, charge will come here only, whether it is conducting or non-conducting. But if it is non-conducting solid sphere, so this whole thing is filled with non-conducting. This is the meaning. So when we take hollow conducting, hollow not conducting, or solid, always charge will come on the surface. But if it is hollow, uh, solid sphere, non-conducting, then charge will be inside here. It will not come on the surface. That time we say charge distribution is charge per unit volume. So they want what is intensity. Consider an insulated non-conducting sphere of radius capital R, charge rho, then electric field at distance r from the center will be how much? So if it is hollow sphere, then intensity inside is 0. If it is solid sphere but conducting, then also intensity is 0. But if it is not conducting, then from distance r from center, where r is less than capital R, that means if point is inside, we can't say intensity is 0. This you have to remember. So now I'm taking a sphere which is solid, non-conducting, that is filled with dielectric medium, and point is inside. So suppose this is sphere, all the charges are inside, point R is less than capital R they have given. So this is radius of that sphere. R point P is inside. I considered one Gaussian sphere of center O, radius small r, it will pass through point P. So can I say flux, which is E bar dot dA bar over closed surface, will be E into, if I take small area dA, into cos of 0, because positive charge area vector will be directed radially outward, and area is E is also radially outward. So this will be E into dA. E into dA means 4 pi r square. So this becomes our flux. Let this be equation 1. Any doubt till this?
No, sir.
No, sir.
But flux is also equals to charge inside upon epsilon naught or not? Charge inside is rho into volume of inside, which is 4 by 3 pi r cube upon epsilon naught. I will equate the two. Therefore, E into 4 pi r square is rho 4 by 3 pi r cube upon epsilon naught. 4 pi cancel. R cube का R cancel. R cube से R square cancel. So E is rho R upon 3 epsilon naught. Do we have this option? Rho R upon 3 epsilon naught. So rho R upon 3 epsilon naught is there na? In C. एक minute. Have you followed this
Yes, sir.
one? See, this is a sphere which is not conducting. Charge पूरा इसके अंदर. Our point P is inside, where R is less than R. So I assumed one Gaussian sphere of radius r. So therefore flux through Gaussian sphere is EdA. Till that we got E into 4 pi r square, equation 1. Then flux inside, charge inside this is nothing but charge. This is rho. Rho means charge upon volume. So total charge is Q into rho into V. V is 4 by 3 pi r square. Everybody has understood?
Yes, sir.
Yes,
Please
sir.
Yes.
yeah, draw diagram and copy from here.
सर
Yes.
सर वो कंडक्टिंग एंड नॉन कंडक्टिंग स्फीयर का और एक बार
देखो
एक्सप्लेन कर दो ना वो
एक अगर
कि किस पे
कंडक्टिंग होता है,
चार्ज बाहर
एक
रहे.
सुनो कंडक्टिंग, तो आपने चार्ज यहाँ पे स्प्रे किया तो ये सरफेस पे आ जाएगा ना चार्ज. कंडक्टर क्या करेगा, चार्ज को सरफेस तक फ्लो करा देगा.
ओके सर.
तो ये हो गया इंटेंसिटी एट एनी पॉइंट इफ चार्ज इज ऑन द सरफेस. ये इनसाइड, इनसाइड तो जीरो है बिकॉज चार्ज ऊपर होता है ना ये, और ये फील्ड ऐसा जाएगा ना.
अच्छा. हाँ.
बाकी सब मैं कल करूंगा क्योंकि दो स्टूडेंट आज नहीं है ना, इससे ज्यादा थियरी नहीं करा रहा.
ओके सर.
So if it is hollow, conducting, hollow, not conducting, solid, सब सेम. लेकिन अगर solid है और नॉन कंडक्टिंग है तो अभी जो केस किया वो हो जाएगा. नॉन कंडक्टिंग मतलब चार्ज अंदर स्प्रेड होएगा, सरफेस पे नहीं आएगा.
ओके सर.
इमेजिन करो ना, एक सिरिंज अगर मैंने चार्ज भर के इधर अंदर सिरिंज जैसा एक पुश किया तो ये कंडक्टर होता तो सब चार्ज ऊपर आ जाएगा ना.
हाँ सर.
इसमें खाली अंदर ही रहे, लोकलाइज्ड हो जाएगा. स्टेट बोर्ड में आप लोग को ये वाला नहीं था, आपको सब चार्ज ऑन द सरफेस वाला था. This Sunday you have test on electrostatics. Done? The next is also very good sum.
Done sir.
Everybody has done?
Yes, sir.
Yes sir.
Yes, sir.
Ananya?
Yes, sir. Yes, sir.
Sum number 79. Very good sum. Two charged concentric sphere. Two charged concentric sphere. Radius 10 centimeter and 14 centimeter. So this is R1 and this is R. And charge on the inner sphere. See, this is hollow, then only it will go inside. Na? Charge on inner sphere is 4 into 10 raised to minus 8. And that on outer sphere is 2 into 10 raised to minus 8. If electric field at R equals to 12 is E1. R equal to 12 will be where? Outside or inside? Hello?
Sir, outside R1, inside R2.
So I can say at R equals to 12, point is inside larger sphere and outside smaller sphere.
Yes.
Reason 12 lies between 10 and 14. So point is somewhere here, correct? Hello?
Yes, sir.
Yes sir.
So intensity due to outer sphere is 0, na? Because point light inside the charge sphere, intensity is 0. So can I say E1 is only K Q1 upon R square. I hope you all followed this much. Hello?
Yes, sir.
Yes, sir.
I'm not putting values because it will be cumbersome. Ratio में cancellation हो जाएगा. So it is K Q1 upon distance R1 square. Please copy till this. R1 12. Completed?
Yes, sir.
Yes, sir.
अभी दूसरा वाला बोला है R is 20. So 20 is greater than 10. 20 is greater than 14 also. So point lies outside both the sphere. Outside both sphere. So E2 will be K Q1 upon R2 square plus K Q2 upon R2 square. Okay, this much clear?
Yes, sir.
Yes, sir.
So E1 upon E2 will be K Q1 upon R1 square divided by K common Q1 plus Q2 upon R2 square. So K I can cancel. So E1 upon E2 equals to what is Q1 given? Q1 4 into 10 raised to minus 8 upon Q1 plus Q2 R1 square will be 12 into 10 raised to minus 2 square. This is 20 into 10 raised to minus 2 square upon Q1 plus Q2. Q1 plus Q2 is 4 plus 2, 6 into 10 raised to minus 2. I hope you all again follow till this.
Yes, sir.
10 raised to minus 8 cancel. So this will be 2 2s are 4, 2 3s are 6. So 2 by 3 into 20 square will become 400 upon 144. So 2 into 72. Clear this much?
Yes, sir.
So 20, 12 का square 144, 20 square is 400. Now any possibility to cancel? कुछ cancel होगा? होगा ना? 4 into 24, 4, नहीं, 4 into 1, 4. Remainder is 3. 4 8s are 32 into 100. 2 into 9, 2 into 50. So 50 upon 27 should be the answer. Okay? B option. Followed? Yes,
Yes,
Aryan?
sir.
हाँ.
Yes, sir.
Okay.
Yes, sir.
Take it. Hello?
Done, sir.
Everybody has done? Can I clear this off?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
See, very important was that 78, if it is non-conducting solid sphere, and this some 79th which we did, 80th. A cylinder of radius 4 millimeter. Radius is 4 millimeter, thin cylinder. Has surface charge density, that is sigma, which is 0.25 microcoulomb per meter square. Is surrounded by medium of dielectric constant 6.28. The magnitude of electric field at R equals to 2 meter, that means outside this, will be how much? What is formula for intensity at any point outside cylinder? Lambda upon 2 pi R K epsilon naught. Correct?
Yes, sir.
But lambda means what? Charge per unit length. But lambda is charge per unit length. Hello?
Yes, sir.
And sigma means charge per unit area, which is 4 pi capital R square. Okay.
Yes, sir.
So we want to find what is lambda. Lambda is charge per unit length, and charge is sigma into 4 pi capital R square. So this becomes E equals to lambda charge per unit length upon 2 pi R K epsilon naught. That means E equals to sigma into 4 pi capital R square upon length into 2 pi R K epsilon naught. 2 pi R K epsilon naught. Length of cylinder is given.
No, sir, just radius.
No, they have not given a length per unit.
Yes, sir.
Length means this, total. This is called length on which it is there. So what is this length? Okay, please copy till this, then I'm doing. Copy.
Done, sir.
Okay. Others have also done?
No, sir.
Yeah, complete.
So done.
You all have done this much?
Yes, sir.
Yes.
Yes,
Yes.
sir.
So if we simplify this, this is 2 pi 2. So we get E equals to sigma into 2 capital R square upon R length into R into K epsilon naught. So therefore E equals to lambda upon 2 pi epsilon, 2 pi cancel. So it will be sigma is given charge Q upon area 4 pi R square. 4 pi R square. So sigma is Q upon total circumference is 2 pi R into R. This will become charge per unit length. So it will be sigma into capital R, capital R square. Sigma into 2 pi R into sigma R. And the epsilon is 0.5. So here I am doing E is lambda upon 2 pi R K epsilon naught. This much you follow? First equation.
Yes, sir.
Now sigma is what? Charge upon area. Area of that cylinder is 4. What is area of cylinder? 2 pi RL. No? This area of cylinder is nothing but 2 pi R into L. No? When you remove it.
Yes, sir.
So when I cut it and spread, so it will become like this. No? This length is, this is 2 pi R and this is length L, correct? Hello?
Yes, sir.
Curved surface area is 2 pi R into L. So sigma into 2 pi capital R is Q upon L. Okay.
Yes, sir.
तो previous में थोड़ा मैंने वो 2 pi R square कर दिया था. So therefore E becomes lambda, that means charge per unit length. This is nothing but lambda. So sigma into 2 pi capital R upon 2 pi R K into epsilon naught. 2 pi cancel. So our formula becomes sigma R upon small r into K into epsilon naught. Now I'm putting the values. This is 0.25 micro. Micro means 10 raised to minus 6. Capital R is 4 millimeter. That is 4 into 10 raised to minus 3 meter. Small r is 2 meter into epsilon naught. K is 6.28. What is 6.28? Is it 2 pi?
Yes, sir.
Yes, sir.
So that means ultimately it becomes 0.25 into 4 is 1 into 10 raised to minus 9 upon 4 pi epsilon naught. So this will become 9 into 10 raised to 9 into 10 raised to minus 9. So it becomes 9 volt per meter. 9 volt per meter. So from sigma, we should know first how to find lambda, which is charge per unit length. Done. Shall we go to 81?
Yes, sir.
Yes, sir.
Okay. Number of electrons. Number of electrons to be put on spherical conductor whose radius is 0.1 meter to produce intensity of 0.36 Newton per Coulomb just outside the sphere. That means small r is equals to capital R, just outside the sphere. Take epsilon as 10 raised to minus 12 and pi as 3. So just outside the charge sphere, E is 1 upon 4 pi epsilon q by capital R square. So E is 0.36, 1 upon 4 pi, epsilon we have to take 10 raised to minus 12, pi we have to take as 3 there. So into Q means N into electron, R is 10 raised to minus 1 raised to 2. So Ne becomes 36 into 10 raised to minus 2 into 12 into 10 raised to minus 12 into 10 raised to minus 2. Therefore, N equals to 36 into 12 into 10 raised to minus 2 to 4 and 16 minus 16 upon n means upon E, which is charge of electron, 1.6 into 10 raised to minus 19. 4 3s are 12, 0.4. So n equals to 0.1 into 9. So 27 into 10 raised to minus 19 minus 114 plus 27 into 10 raised to 4. Do we have option? Yes, we have as 2.7. This is same as 2.7 into 10 raised to 5. So option A is the correct one. A. Can I clear now?
Yes, sir.
Yes, sir.
Yes. For diagram, this is direction based. Next one. 82. 3 infinite long charge sheet. So first remember for charge sheet, E is sigma upon, hello, for charge sheet, sigma upon 2 epsilon naught are placed as shown in the figure. This is the formula. Now we are drawing the figure. Here Z is 3a, charge is sigma. This is the point P. Z equals to a minus 2 sigma minus sigma, Z equals to minus a, and here they have told x-axis, and this is z-axis. Point P is here. So for point P, Z3a and sigma, where will be intensity, outward or inward? Say sigma is positive, so for this sheet charge will be, intensity will be outward or inward? Outward होगा ना, positive charge के लिए even. Hello?
Yes, sir.
Yes, sir.
Outward ना. अब ये इधर है दूसरा, Z equals to a, लेकिन charge है negative, so it will be inward, no, towards this. Correct? Hello?
Yes.
Yes, sir.
ये तो inward आया, मतलब from here it will going way towards that E2. Right है ये? Diagram right है क्या? इनवर्ड आउटवर्ड का कॉन्सेप्ट फिर आपने दिमाग से निकाल दिया. This is the charge here, Q. This is the point. This is inward or this is outward?
Inwards.
Inward.
और इधर से ऐसा बाहर रहेगा तो आउटवर्ड होता है ना.
Hmm.
तो अपना ये -2 सिग्मा इधर है, तो ये चार्ज इधर निगेटिव ऐसा हो गया ना, तो ऐसा आना चाहिए ना E2 इनवर्ड टुवर्ड्स द चार्ज ना.
Yes, sir.
वो डायग्राम रॉन्ग था ना अपना. ये पॉइंट है, ये पॉइंट से ऐसा रहेगा तो आउटवर्ड बोलते हैं, ऐसा रहेगा चार्ज का तरफ तो इनवर्ड बोलते हैं.
Hmm.
अब अभी समझ गया. Because if you know direction, then only we can add, subtract. Z equals to 3a, charge is positive, this is the point, this is even. And for Z equals to a, this is -2 sigma, so this will be intensity from P towards the charge, that is called inward. This much clear?
Yes, sir.
Yes.
अब ये नीचे Z equals to -a, उसके ऊपर चार्ज पॉजिटिव, तो ये P is here, ये X है इधर, इधर से P से आउटवर्ड चाहिए ना अभी हम लोग को. ये चार्ज कितना है, माइनस सिग्मा, तो ये माइनस सिग्मा, तो उसका भी ऐसे हो गया ना फिर इनवर्ड E3. Clear?
Yes, sir.
So all the three are in same direction or in opposite?
Same
Same
direction.
direction.
So
Same.
resultant intensity will be E1 plus E2 plus E3 or not?
Yes, sir.
Okay, just copy till this. Then we are putting E1, E2, E3 value.
Done, sir.
So resultant intensity E is sigma upon 2 epsilon plus 2 sigma upon 2 epsilon plus sigma upon 2 epsilon naught. So LCM is 2 epsilon naught, 2 sigma plus 2 sigma plus sigma plus 2 sigma plus sigma only. 4 sigma upon 2 epsilon naught, 2 into 2. That is 2 sigma upon epsilon naught. So E bar equals to 2 sigma upon epsilon naught. All are acting opposite to Z. So minus K cap. So it will be minus 2 sigma upon epsilon naught K cap. Okay. Done?
Yes, sir.
Yes, sir.
So today we are doing this much only. If possible, do 10 more. If not, then don't take tension. Revise only whatever we did. Tomorrow our lecture, as usual, our time 12:30. Is it okay for
Okay, sir.
tomorrow?
Yes, sir.
Yes, sir.
This week, anyhow, we have to complete this chapter with theory and MCQs. Okay, bye.
Bye, sir.
Bye, sir.
Okay.
Bye, sir. Thank you.
Bye,
Bye,
sir.
sir.
Thank you.